So it is the top of the hour. Hello, everyone. So this is a meeting of the SCHC working group. So in case, no, this is the right room to be, right? Yes, it is the meeting for the SCHC working group, and we're going to start. So people will be joining, I suppose, gradually reconnecting. But we have a pretty tight, pretty full agenda for today. So we're going to get started. First, we are going to start, of course, with the Note 12. You've probably all read this one several times, but I really want to insist that by participating in the IETF process, participating in the IETF, you agree to follow the IETF processes and policies. This Note 12 is a reminder of some of those policies, and there is a link there or you can use the QR code to read all of them. IETF participants are expected to behave in a professional manner and extend respect and courtesy to their colleagues at all times. And if you have any concerns about behavior, please contact the Ombuds team, who will handle this in a very extensive way. Also, if you are aware that any IETF contribution is covered by patents or patent applications that are owned or controlled by you, your employer, or your sponsor, you must disclose that fact or not participate in the discussion. You have a bunch of references that normally you should be reading, offline in your time, but they're all in effect. And if you need any advice, please talk to the chairs or the area directors. So Eric is here with us. Thank you, Eric. And by saying chairs today, we are with the delegate chair, my co-chair of today, Laurent Toutain. So Pascal was unable to come because he had a minor surgery, but he's doing really well. Yeah, we are thinking about him and being, resting and recovering from that. So this session is being recorded. If you're in the room, make sure to scan the QR code and to log in to the session. So you should use the on-site tool. It's a little bit lighter on the network. If you want to go to the mic, please raise your hand. Before going to the mic, this way you can be in the queue. And for the people that are remote, please keep your audio and video off, unless, of course, you're presenting or you want to ask a question. So yes, and the use of headset is strongly recommended. So these are the regular links that we have for the resources. The agenda is there, the meet takeover and other information. Also, the notes are taken. So there is the link. I also put it in the chat on the client. So we have our note takers. Alejandro, thank you very much, Alejandro, and Marco will be helping. Thank you very much, Marco. Of course, we will also be lending a hand. And we have our Jabber scribe, Renzo. Thank you very much, Renzo, for that. So that's that. And with this, we'll do an agenda bashing. So this is the agenda, it hasn't changed. We start with, we'll have a short report from the hackathon. Then Bob Moskowitz is going to present us the evolution of the protocol numbers. We have updates on the SCHC 8824. Laurent is going to present about the seed allocation and evolution. Then we'll have some core comp management update from Alejandro. Then there was little changes since the last time that the agenda was published. We'll have then the SCHC minimal architecture presented by Quentin and Marion. A short discussion on considerations for core conf management for point to multi-point links. And then we'll have also Rodrigo, who is going to be presenting SCHC over direct to satellite IoT. Do you have any? So we have pretty tight agenda. So we'll try to keep the timing. Do you have any items or any suggestions for requests for changes? None. So, yes, so none. So with this, we continue with a short overview of the evolution of the documents that are currently under work at the working group. So things are evolving pretty well for a lot of the documents. So we'll have presentations that discuss this today. Where I'm not going to go into much detail on that. There is, of course, the ongoing work on the SCHC architecture draft, and we'll have a lot of some discussions on that as well. Yes, probably we'll have some drafts that at some point we'll have to have. Oh, yes, Laurent.
Yes, well, would like to have a clarification regarding ICMPv6. I don't remember the status, if we made the last call on it, and what do we do next with this document?
I need to double check. I don't recall if we made a last call on that. But
the document is ready for last call or has been passed to last call, so we have to make it evolve.
Okay, so thank you. I'll double check this one right after. So yes, some of these documents, of course, are here just to fuel the discussion, like to add points to the discussion. They're not supposed to become, to evolve into RFCs. Some others are going to be in real interest for the working group. I think about, of course, the core conf management document. We'll need to the DIA TSP. It is not in our working group, but it is an important document, so we should really review that and continue working on it. And there is, I think, some pretty interesting work that can come from the SCHC compressed payload draft. And with this, the administrative part is over. So I'm going to give the mic to Alejandro to give us a little update on the hackathon.
This one. Hello? Yeah. Do you have the timer or no? No, it's okay, it's fine. Whoop. Okay, yeah, so for the hackathon, we focused mainly on the SCHC core conf management capabilities. So this is about enabling the context management in SCHC. Where's the waypoint? Yeah. So why do we do this? Basically, SCHC has been attracting attention from other environments, and so we need to adapt now. There's a need to adapt to dynamic traffic types. So if the context, the context has to evolve over time based on the detected traffic patterns. So we are writing this draft, and we decided to integrate CoreConf into the equation. So basically, we introduce management traffic in the form of requests and responses to manipulate the set of rules. So yeah, we handle fetch, IPatch, and post operations. This will mean that we start from generic rules, and then as we detect traffic patterns, we make more specialized rules, and thus we achieve hopefully better compression So this results as a byproduct. We end up with a hierarchical set of rules, where the rules at the very top are more generic. So, for example, they only compress the version field of IPv6. And then as we descend into the tree, we compress more and more fields. And so this optimizes a bit also the rule selection process. And for the hackathon, we focused on the demo, so it's a proof of concept we have. We basically have a device sending some uplink traffic. And here we can see, I'll come back to it a bit later in the draft description, but we basically, here for example, we basically managed to compress from 72 bytes to 43 bytes, and then we do a management request to compress a bit more. And finally, we compress from 68 bytes to 37, so it's a bit more compression. And yeah, I'll come back to it in the next presentation. And well, that's it basically for 3 minutes. CoreConf is very, very efficient. We are able to optimize compression rules on the fly.
Thank you very much.
Thank you very much.
Thank you, Alejandro. So yes, really interesting. This has been which hackathon? I don't know, but there has been SCHC hackathon ever since IETF. I don't know, maybe 7 years, 8 years. So I think it's really, really super interesting. So Bob, it's your turn. Let me. Yes.
Get down to my size there. Okay, Bob Moskowitz here. Thank you for this time this afternoon. And this is now a group draft. It's no longer just me with Pascal working along with me. We've had Anna and Carlos joining in the front on this. This started out as an effort on my part to get SCHC at the Ethernet level as an ether type. It bounced around a lot, and we finally got some good input on how we can now do this also generally on the transport level. So this is more about what has been added since the original set of drafts, which dealt more with ether type, and now taking this also up the stack to the transport levels. So next slide, please. Where's the quicker wording there? Okay, so we've added UDP, connection-oriented communication, and I want this generalized, not try to say which connection-oriented one, but talk about that generally. And also that the port numbers become the SCHC identifiers. The three important additions which have come up in the work we did added in over the summer. So the UDP is needed to allow carrying SCHC compressed data units atop UDP. The port numbers are needed to identify when UDP carries a SCHC datagram. That is, there is a SCHC stratum atop UDP. That's how we're doing this, that using the port number, instead of having a fixed port number for UDP, it is what you select, and that then becomes your stratum number. For example, when SCHC is used to compress co-op messages, it can be used for this. There is no 6 low-pan, 6-slow style header compression defined for co-op, and here we're able to do that. So that's the draft there for 6-low SCHC, which is there. So this gives us a more generalized approach on the UDP than we've done in the past, and we did not have to ask for a specific UDP port assignment, but rather how that is assigned, how then we then use that in the stratum header. And that's really Anna's work on how she worked that out. So so that's the UDP edition. Next slide, please. And SCHC protocol numbers, port numbers, and protocol numbers as identifiers. This is a very important point which we've done here to avoid confusion when receiving a SCHC compressed packet. how the identifiers are used in the discriminator so that you can say, yes, I got SCHC here, and this is the port number which I'm going to be putting into into my transport layer. So you take the SCHC stratum header, it would take that out, and now you have your port number. We did not have to ask for specific assigned port numbers. That got us out of saying, please give us some port numbers. So this is the protocol number at layer 3, whatever it is, and the port numbers at layer 4 is how this is structured. Again, Carlson did this part of the work. I believe Carlson and Anna, how they divided it up on the work. So I was the editor to put the text in. They're the ones who came with these great ideas of how to do it. So recognize that particular role division. So now we have these pieces in there. We now have how to do the ether type, how to runs directly with what I want for what I want to do for aviation, and now for others who want to use this at the transfer layer with UDP or connection, whatever connection-oriented transport it is. So we have now this generalized across the board for this approach. Next, please. And so really, that's it. I think it's a very clean, simple document, lays it out. We backed off from giving specific port numbers. We've worked out how to use the stratum header to do that. And then and of course, ether type, we do have to ask for a specific ether type delegation for that, but there are a specific way to work with the rack to get that done in the IEEE 802 rack to get that allocated. So we're ready for last call. We believe we got everything in there. We need people to read it over, comment, any cleanup of text, anything needs to be expanded on. Let's get that taken care of, and then we can move forward on how we do this. I said, we basically have gotten IANA out of it. We don't have to ask for a specific port number, but we do have to go to the IEEE rack to get the ether type assignment. But there's a specific procedure for doing that. It's that simple. Any questions? It took us a long time to get there. We're here now.
Mark is coming to the mic. Okay.
Need to go up to the Marc Blanchet. I'm involved with space networking, and so there's a CCSDS, which is defining the link layers for space links. And we need a code point in their registry, in their CCSDS, called the IPE header. I can give you the URL of the registry. They have similar to SANA. It's to IANA, it's called SANA. I actually founded it. Can we add like a section on this so we can use this for then asking CCSDS for a code point?
I would think this is a place.
Another draft that,
Yeah, I think this is a place to do it. You came just in time.
Right.
You came just in time.
Okay.
And definitely this is a place where we're doing that. And
Okay.
It's just another link layer, another transport, another
link layer.
Yeah,
It's like Ethernet, but
yeah, it's like Ethernet, exactly.
Yeah.
So let's grab the opportunity here
Okay.
and get
because SCHC is
and work with
really
me.
useful for space.
Work with me, get me the text, and I'll rev it in. Great. And of course, here comes our AD to comment on that.
Yeah, Mike, don't go too far away. There is no official liaison, right, with CEO, this SDO. So what's the procedure to get this?
Yeah.
Detail.
I can help. I know all the community, but that's going to be probably the first time ever that they would get a request from outside. So, but I know
It's a secret handshake.
Yeah, I know everybody there. So.
And the other point, is it a point-to-point link?
Yeah.
So it's not like Ethernet.
No. Well, no, but But it's
There's a
good
major
point.
difference, right?
It is different, but it's similar.
Yeah, right.
Yes and no, right? Because internet is multicast, it's broadcast.
Right.
So you need to identify to whom you are going. Here,
Right.
there's a point-to-point. So that's vastly different in this context, I think.
You're right, but, okay, it's a link layer.
But also organizationally, 802 is a very structured organization, and the RAC is a very structured group. And for those who have worked with the RAC over the decades, you're the new guys on the block on this, and a little bit more. We'll figure out how we go and get it done, and our AD will help us. So Graham, we got that just in time. We'll take care of it. We'll get that in. Anything else? So obviously last call, I got to get that in before I can really go to the last call. I got to have that part in.
Donald Eastley, just the exact procedure for getting ether type is in RFC 9542.
Right. So that is well documented.
So I have a question.
Yes.
And thank you. So I read the draft, the updated version. So it is significantly, I think it addresses a lot of the questions that were asked during the early reviews from the Inter and TSV Art. How, maybe that's also a question to Eric, how should we proceed here? Do we start our last call? Because there are some minor details to be like fixed, but that's normally what we will do during the last call. And then when we end the last call, then we can go to ask again for a early review, or just we, do we need to do this then?
So Eric, you can request early review anytime as a chair. This may be a good idea, but when you do working group last call, I would suggest that you forward the working group last call to TSVWG to get more people.
Okay, we definitely have last call and everything which is in there. Yes, we're adding the satellite text, but we should definitely get the rest of it going and get that through the process. And also what we need to do to actually get that, following the RFC, to get that ether type allocation moving along.
Okay, so we'll start a working group last call, and that would mean that we would really like for the working group, so people from the working group to read it. It's really not a big document, and it's very easy to read. So please read it and like suggest if there are minor fixes or things to be fixed, so that we can move on with the process. Right?
Yeah. Writing is fun for me because I'm dyslexic. Okay, thank you for your time.
This is why you're good in encryption and stuff like this. Thank you very much, Bob. Okay, so yes, next up, Marco, and just give me a second to switch the slides.
Okay. Yeah, thanks. Hi, everyone. This is Marco. This is an update on the document for using SCHC to compress scope headers, now in version 6. Yeah, and as a recap, this document, since almost from its inception, is intended to formally obsolete 8824, and the scope is pretty much the same as of this document, mostly intended to give a number of clarifications, also related to errata that had been filed. And one main point of novelty in this clarification was explaining how SCHC for COP is used in the presence of proxies. That was not covered in the original document. And then over time, we found a few more things to clarify that I tried to squash here. And I stress it's really about clarifications, that there's no breaking change really related to the core mechanics of SCHC at all. And there's a lot of examples. I just highlighted with new here the latest two new points added in this version, mostly the result of discussions at and right after IETF 123 in Madrid. Other minor clarification and fixes, the main updates are about trying to be as clear and crisp as possible about the use of FL infield descriptors where variable length header fields are involved. The old text was consistently building on the general pattern written in 87-24, but there was some room for misinterpretation or ambiguity that we hope to have clarified now. And that's for section 3.1. And then there's two paired points for section 4.3 and 4.6 about generalizing the compression of two fields, the co-op token length field and the co-op token field, and well, the corresponding TKL function, considering that a relatively recent RFC has actually admitted an extended format for the co-op token field. Examples have been updated, not really in terms of message compression. They don't change because of these updates, more the examples for the compression rules that now follow up to these updates. So taking these points in order, on clarifications about how to use or what to have in FL for a descriptor of a variable length field, we tried first of all to explain better what variable length field means and its variable length for the protocol. So when using that protocol, you can have that field having different lengths in different messages. And like said already, typical examples for co-op are the token field or the value, to be specific, of its co-op options. That said, what to do exactly in a field descriptor? Well, it depends on CDA used in that descriptor. If it's not sent or mapping sent, that's trivial. FL is basically not set. That's the parlance we've been using now consistently, or empty, if you want. There was a mix of cases in the example where sometimes it was empty, somehow it said var, where actually there was just nothing to do because the length of the field can be determined by the content of TV. So now we nailed this down for not set. Of course, it's a totally different story instead if CDA is value sent of LSB, and then you can actually have three cases. First, even if per the protocol, the field is variable length, you may actually be in an application or network deployment where you are sure that you are going to match a rule with the descriptor where you have an exact number there, because you are sure that irrespective of the variability in the protocol, in your case, that field is always going to display a certain length. And then you can go for a fixed value. Admittedly, can be a corner case. The most common case is the second one instead, where the intention is to indicate something called var in general terms. And considering what is specified in 87-24, var or something around that word is supposed to tell you not only that you really expect something that varies on a per message basis, but SCHC is going to send on the wire the residue prepended by the size of the residue in the unit specified by var. So what does var exactly means? Because there can be different units and some can be more convenient than others depending on the situation. So we specified here that var means the unit is byte. We defined also a similar function var bit where the unit is bit instead. And we just say that, well, future specifications or profiles, whatever, can define the further var underscore full, just to indicate yet another possible unit. And then, of course, a third case that is covered already in 88-24 here, and something analogous for other fields is to define yet another even more custom function like TKL for the token field, or another similar one we are defining in another section. And an important observation that we added, it was never written down, is that, well, that builds on a pre-requirement. You need to be able to compute that function, which implies you can do that taking as input information that you have in the header before that field to which that exact function applies. Yeah, I partly covered this in the previous slide. In the section when the use of var is described, again, we go through these variants, and the difference is really only about the exact unit to consider for the size of the residue prepended to the residue on the wire. For what is worth, I think this will come back in other documents in SCHC that compress headers of other protocols, and these are generic things that may apply very much somewhere else. On the other hand, well, it wasn't well received, the idea to make an update to 8724 about this for the sake of generality, or we even dismissed the idea of even more errata to 8824. So we put this text here. I believe it's a starting point for future documents that are going to go through the same considerations again. And the updates to the examples that I mentioned before are, again, in the example rules, in the related tables, and are essentially because of this. So being consistent in what to put in FL in the right descriptors. A more interesting part, extending a bit the processing of the token field of the co-op header to be consistent with what was enabled in RFC in 8974, that of course came after 8824, where this was not covered. So original, the TKL field framed in green there and supposed to indicate the length of the token field was exactly of 4 bits. And that's it, and it was supposed to indicate the size of the token field to be between 0 and 12 bytes. Enter RFC 8974, and it admitted an extended token field and an extended token length field, with the caveat that the token length field TKL framed in green is not perfectly contiguous. So you still have the first 4 bits in the original place. And depending on its value, it's just like in the original co-op RFC. But if it takes specifically the values 13 and 14, it's telling you that this information continues 3 fields after in what is called TKL extended in the figure and framed in purple. And then you are supposed to check that latter part to finally understand the size of the token field. But overall, the TKL field is 1 field. Only it can have an extended format where the extended part comes a bit later. But semantically speaking, it's a single field, which is good news. It doesn't really require to make any changes to the data model, for example. In there, it was framed already and presented already as a field indicating the length of the token field. And that is still the case. According to this particular encoding. Once we built an understanding of that, and it's now also explained in the document, well, it's essentially trivial or close to no action to update the behavior of the TKL function. And this function is still supposed to determine the length in bytes of the token field based on the content of the TKL field that just in general has to be parsed, taking into account its extended format updated by 8974. And again, no structural changes about TKL as a function either is required in its entry in the data model. Okay, while I was at the airport about to take the flight to come here, we received an early review from Ayana with 1 comment related to a new registry that we are defining here. And the registry is intended just to be a catalog of documents that define ways to use SCHC to compress fields and in particular options of the co-op headers. This was considered a good trade-off to decouple altogether the definition, registration, update, whatever of co-op header fields on one hand, and the possible definition and possible revision of SCHC usage on those fields. So this registry is just supposed to track things in that sense. The question from Ayana is, are you going to put this registry in some existing registry group, or do you want to create a new registry group? I'm not sure what the final answer, but personally my proposal would be to create a new registry group like SCHC parameters. And probably this registry here is not going to be the only use case. I can imagine that the SCHC type registry that is mentioned in the draft that Bob presented before will be a second registry part of this group. So I'm not sure we need this answer now, but to me, it makes sense to create the registry in either of the document and have, well, both registries then, including this one, part of that group. Right. The only next steps I can imagine are, addressing that IANA comment, I believe creating the registry group. And then we have, in the section related to the compression of the Oscar option, some content taking care of an ongoing extension to the Oscar option that is happening in a document in core. So this particular content is a subset of this section and is specialized on what is being added right now to the Oscar option. So in principle, you can isolate and extract that content away. And that was I was thinking to do because I believe this SCHC document, not by far, but still is going to be completed before the core document. And just to avoid a normative reference that can block and create delays, I was starting to think to extract that particular part of section 6.4 about the extended part of the Oscar option, move it out from here and put it in the core document. As a result, well, we have less text in the first place, and the reference to the core document still remains in the interest of other sections, but it can become informative, I believe. And that will simplify the process on the way forward. So I can imagine these two steps, the IANA comment on creating the registry group and moving out that particular content away from here to the core document. Other than these two next steps, I can't imagine anything else to add or clarify in this document. So the next step after that would be working group last call. And if those 2 points are not strongly expected before considering that, to me, this version already can be considered, and then we can take care of those 2 points when addressing the comments from the last call. Up to you. Thanks. There is a Christian in the queue,
Hello, Christian Amsus. If it makes things easier for you, you might also just do the move the text from the core document in here and do the generalization of the Oscar option in here. I'd be the designated expert to manage that, and I don't have any strong preference in which document that happens.
Probably. The text really talks about those 2 new fields added by the Kudos protocol, so I'm not sure how much it can be generalized. All the general part is fine to stay here, actually.
I was thinking about the part where it's talking about the reservation of the new bits, but if it's just about the complete bits, in that case, yes, can't do much here.
Oh, that's covered and doesn't require any particular thing because we talk in general about the flag bits subfield. It's covered already. So yeah, in practice, I can either produce a new version addressing those 2 points or instead not. And we have a last call on this version.
Okay, so yes. Thank you very much. Like the document is really advancing very actively, so that's really great to see. Actually, a couple of questions. There are a lot of questions. The first question is, even for the variable length fields, the way you described it, you said that probably can be generalized, but you think we should not be doing that?
No, sorry. I think what we wrote is general and will come again reusable as is in other SCHC documents for other protocols. So my personal preference would have been to write that as an update for 8724. That didn't feel like a good idea for someone. So this is fine. I expect that text to be reused 99% in other future documents, which is fine.
When you say reused, it's like it's going to be copy pasted, or someone can say, well, we are doing the same thing as...
Almost copy pasted if that same line of thinking is applicable, and I believe it will be.
Okay. Okay, so that's not like a blocking point for the moment. The other questions for the registry from IANA, and here, like my personal opinion is that, yeah, I mean, doesn't seem like a bad idea to ask for a new family of registries for SCHC. Then again, probably it's good to, like every time that we were dealing with IANA, is just go and talk to them and explain like how the process is working and get feedback from them also to see what is their position about that.
So creating a new group was one of the options they were suggesting, actually. I've never written text for doing that. I hope the simple sentence, this register is part of the newly to be created register group, would be good enough. Otherwise, they tend to do early reviews for every working group document in the meeting, and they'll come back to us again and again.
Yes. I don't know if anyone in the group has any strong feelings about that. No raising hands, so probably like you can go with
And probably that particular text can be moved back and forth between this document and Bob's and to stay in the first document, I guess, to the ISG, I suppose.
Yes, that sounds like a good idea. Okay, so that was this point, and the other point was, of course, about so the question about the specific things about OSCORE and moving that to the OSCORE document. I mean, like there are a lot of people here from the core working group. I don't think that there will be any problems if this part of text is moved there, so we can do reviews.
Well, it's important to have around those compression guidelines. I think they have to be somewhere. It felt natural here, but if risks delaying this document, they can be there, and it's fine anyway, because that's where the extensions in the option are defined. So either is appropriate, whatever comes latest.
Okay, so with this, can you maybe have a show of hands if how many people have read like the latest version of the document that are here?
Me for sure.
Okay, how many have read an earlier version of the document? Okay, so we have a couple, like 5-6 people that have read it. So I think that one of the things is it seems to me that you have you have the feeling that it's there, the document is there. All the points that are questionable, that like you could be blocking, you have a way of to resolve them, right? So just go ahead with that, and we can start a working group last call. That we would ask for people to review the document, right? And
so other than those 2 points, I don't have anything else. Should I produce a new version addressing those 2 points?
Yes.
Ah, okay.
Yes. Produce a new version.
Yes, sure.
And so, are there people in the working group that are willing to review the document? So yeah, I think that we'll go ahead like this, like we are, so we can produce the version, and then we'll start a working group last call, and then we'll have reviews. And I mean, I think there will be probably some needs to fix, but that's always as expected, right?
I'll try before the holiday season. It should be possible. Thanks a lot.
Thank you very much, Marco. Thank you. So we're a little bit behind the time, but it was really important. And as you can see, documents are advancing pretty well. So let me just change the slides here.
Okay, so I will talk about seed allocation. So I hope it will be a discussion, because it's a new thing that we are doing right now. And so there is a lot of procedure that we have to discover or create. So just to remind you a little bit what we have right now. So we have the RFC 9363 that developed the young data model for the SCHC rules. And we have also some values that have been allocated for seeds. This is a range from 2,550, and it's a range of 450 values. So the first thing we have proposed is to do a manual allocation of the seed values, not to use the Pyong tool, because Pyong tool is ordering things alphabetically and so is not very efficient. For example, you have row ID, which is a number, you have start with an R, so it's very far away, and so we need 2 bytes to code this value instead of 1 byte if it was at another position. So we can rearrange things, and it's what we proposed during some interim meetings. So instead of allocating linearly things, when we go deeper into a branch, we add 23. So we have more room to put things together. So we have a place for fragmentation, a place for compression, and some place also for the identity. So here this is in some documents, so the universal option document where you can see discussion about that. So we have also another young data model that has been developed for SCHC. It's about compound acts, and this young model doesn't have currently some seed value allocated. We have also 2 other documents that are almost finished. It's the update of 8824, and it's the ICMP v6 that have also some young data model. We have also 2 other documents that are now in the working group that are not totally finished, but one is universal options, and the goal is to suppress co-op identifier or co-op option, identifier for co-op option, and use the number used by co-op, which makes this thing universal. When a new co-op option will appear, we have automatically an identity into SCHC. So that's easier to manage, but it's something new. And we have the management document, core-conf management, that define RPCs and other the things. And Alejandro will talk about this one. So if we follow the procedure that are defined, it means that we can ask a range, a range of value for all of these young data model. So that's a solution. The problem is that we are having larger delta in the structure, which means that we are spending more room to store the information. And since we are in SCHC, what is important is to try to reduce the size of it, so to manage very carefully the delta in the representation. So that's why what we propose to do is, in fact, to use the range we have for RFC 9363 for all these different documents. So it's not possible like it is right now, but what we can do is to issue a revision of 9363, including all the information defined in this other young data model. So this way, all the information will be part of 9363, and then we can allocate this range to all these different things. So that's a good solution, but of course it's not so easy because we have universal options that appears, and as I say, universal option is obsoleting co-op options that we have in 9363. So what we can do is not to allocate co-op options in the seed file. So they will, for a certain period of time, they will not exist officially. And but we can continue to use the options that are described for OSCORE, as Marco explained before, because this one has to be known, because we split OSCORE option in smaller options, and here we need a knowledge, so it's good to have identity for that. So if we do that, so we can have this tree. So what we can do right now is what is in blue. So it means that or dark blue, it means that we create what exists in 9363 without the co-op options. And we start working on the revision of 9363, including what is in light blue. It means all the documents that have already some young data model. And this way, we can publish the seed files that will be very efficient to compress the information. So now, what do you think of this proposal? Is it legal regarding to INA procedure or a young procedure? For me, it works well, but I'm waiting for comments.
Okay, thank you very much. So, pretty interesting proposal. I haven't seen that before. Basically, having like the RFC 9363 and like put all the identifiers that will be that are necessary, like in an update, so that we can reuse the same seed range. So pretty interesting. All right. So I think that there are basically two questions. Like this is the first question, and the second question is not to allocate seeds to the co-op options. So
Yeah.
they are basically they're separate things, right? So on the first thing, personally, I think it's a good idea. Like it's a neat idea, and it will save seeds. It will save deltas. So sounds like, at least to me, like really the smart thing to do. So with this, I personally fully support that. I don't have strong opinion about not allocating seats on the co-op options, right? It feels a little bit like we've made some kids and now we're going to obsolete them and forget about them, and put them in the hole, and they didn't have they will never have the seats they deserved, right? I mean, there is an RFC today that uses them. So I personally feel a little bit odd about that, right? But probably that there needs to be some more people from the working group to
It's
say
not
how they feel about that.
It's more for beauty because, in fact, identity are not coding in delta, so it's just a value. So we can lose a little bit more things or put them at other places. It will not be really a problem for the present representation. But it means that we are now allocating things that we know will be obsolete soon. And I don't think that right now a lot of people are using this in commercial products. So maybe we have time to think and not to rush and allocate them. So that's, but if we allocate them, it will not be a problem. It's that we are losing about 20 values that will never be used in the future.
So I'll have maybe a mini question to Karsten, because he's one of the other fathers of the SID universe, and these are like the first stars in the SID universe that are appearing. So what do we do? Do we allow this impurity of not, in your opinion, of course, of like creating a Yang module, then obsoleting parts of the things and not allocating SIDs to these things? Do we allow that, or in your opinion, right? Or should we at least give names to these stars, even though they will go dark?
Well, there are thousands of Yang modules out there that don't have SIDs. So, I mean, we are not changing anything to the worse by saying, folks, these SIDs will never be used, so we don't allocate them. I think that, well, basically the way RFC 9595 is structured, it essentially gives a lot of control to the designated expert. So the designated expert is supposed to generate those files, and if something is missing and the designated expert can explain why that is missing, I think we are fine. What we should never do is take a SID that has lost its meaning and assign this to something different. That would be bad, because the whole point of registering these things is that we can translate between the numeric SIDs and the alphabetic Yang identifier. Sorry, I forget the name. And this assignment should, if at all possible, only ever grow. Should never be in a situation that there is some outdated mapping in some database, because that will percolate through your whole system and do bad things to you.
Actually, you're perfectly right about the point that there are many Yang files that don't have SIDs. Here, the thing that is rubbing me in a strange way is that this is a Yang file that we have that is going to have SIDs, and it's actually a Yang file that's specifically for IoT, and where we're looking a lot at SIDs. So basically, it's like a thing that is destined to be used with SIDs, right? And we're basically saying, okay, these things really will have not existed, like they didn't exist at all.
So if you don't have a SID, you use the text-based representation. If you don't use that part of your specification at all, then it doesn't hurt to not use text-based representation. So I think we are really safe there.
Okay, good point. So, Laurent, I think that you have your answer. I mean, I don't think there are any other strong opinions on the topic, right? I think you had like your two answers to the questions, like about.
Yeah. So what we can do now is to publish this document and ask for a careful review, because it has been done manually. So maybe we can miss some seeds or have some confusion. So before submitting it, to have a good review from the group about that.
Yeah, so I think we need to be pretty careful in keeping track of the Yang modules we want to do manual allocation for. Because what I'm doing right now is doing automatic allocations for all RFC or Yang modules that are in RFCs, and RFC 9363 is an RFC. So yeah, you need to be careful.
Okay, I have never thought about that, but yes, in addition, yeah, so really, really good point. So Alejandro, you're next. I will put a timer. Shorter, maybe.
Yeah, it's fine. It's fine. It's fine. It's fine. Do you tell me when to start? Yeah, so now I'm going to elaborate a bit more on the. So this is work that's related to what was done in the hackathon, and yeah, so this is the draft we're working on. So very quickly, I'll have a bit of less time than originally thought, but it should be good. So first, I'll talk about why we are doing this. Basically, explain how it's applied. I'll go a bit deeper into management traffic. There are some notes on security and optimizations. There's the proof of concept that was recently advanced during the hackathon, and there's a wrap-up. So, yeah, you just saw this. So basically, we need to adapt to evolving traffic patterns. And for this, we use CoreConf. So we are going to manage the context remotely. So between endpoints, we should be able to, for example, if the SCHC core or any other entity detects recurring traffic patterns, should be able to send an update to make compression better. So initially we were saying like we can modify existing rules. We've decided to get rid of that because it introduces some instability in the context synchronization. But instead, we can add new rules, delete existing rules, and trigger RPCs. So this is defined in CoreConf draft, but we have defined so far the duplicate rule RPC, and basically this will derive a rule, make it more specific. So in the diagram, we can see like initially we have like the blue context, like the first version of the context. There's some application traffic which is compressed using this context. After this, there's the management traffic, which updates the context, and finally the application traffic can be better compressed, hopefully. So this is a distinct traffic from the application. So it uses its own application stack. So in the application, like in the application traffic, we can have like anything like lightweight M2M or whatever. But for application, so for management traffic, we need core conf. So that's the co-op part. We've managed to implement, so we're defining fetch, IPatch, and post to trigger RPCs, such as duplicate rule. And this management traffic is compressed using M rules. So for example, we have a couple of rules to enable uplink context management, and a couple of other rules to enable management in the other sense. And there's also a guard period. For example, when we delete rules, we want to make sure that, for example, deleted rule 8 is not used during a certain time. So this is the rules that we're proposing. So this is just very theoretical to show that it's IPv6, UDP, and COP. The main difference here is on one rule, on one set of rules, we're defining basically requests or responses with payload, and the other rule just includes response codes, basically co-op responses. So in this case, for example, in one sense, so if the SCHC device manages the core SCHC gateway, we use the first set of rules. And so this gives flexibility because we can block or protect context management in one sense or the other. And we specify protected resources. For example, we cannot delete management rules or create new ones or delete things like the rule ID identifier, for example. And to talk about the duplicate rule RPC that we managed to implement and that we're defining, basically we create more optimal rules from generic ones. So we begin the scenario with a very generic rule that compresses any type of traffic, but it doesn't compress it very well. And as traffic patterns appear, we can copy from a rule to another rule, including an IPatch sequence. So I have an example of this a bit later. So as a byproduct, we have a hierarchical structure of rules. So we're going from more generic to more specialized ones. For security considerations, well, we are saying that it should be encrypted. Normally, of course, depends on the scenario. The set of rules can only be manipulated through these M rules. So there's a protection system. And we only derive from existing rules because we need to optimize requests and omit redundant information. We're still working on that. And yeah, so the hierarchical tree. So this expands a bit more on the demo of what was done in the hackathon. So yeah, first we have some packets that were measuring 72 bytes. So it's like a constant flux of uplink. And first we were compressing using rule 8. We were achieving a certain number of compressed data. Then we send so this is the point of view of the IoT device. So then it receives a management request that costs 51 bytes. It's a duplicate rule. So we copy rule 8 to rule 9. And in the IPatch sequence, we say, okay, now you're going to compress the flow label. So we can see then that now the device is using rule number 9 to compress the packets. And we save 2 bytes per packet. So of course, then we have to evaluate, okay, we sent a management request that cost us a certain number of data. So in this case, for example, at 25 packets later, there's the return of investment. So yeah, so CoreConf is very, very efficient to manipulate this. Thankfully, we have the experience on implementing it. This helps us, of course, write good standard, and well, hopefully. And yeah, so we have compressible and encrypted management traffic, which is distinct from the application traffic. It serves only the purpose of managing the context, and context can only be managed with these rules. And yeah, we were able to optimize compression on the fly. And yeah, we forbid basically modifying rules with iPatch to prevent context mismatch, etc. Yeah, so actually this is a point that we want to elaborate a bit on. So if we only allow new rules to be created and not modify existing rules, eventually obsolete rules should be deleted instead of modified. Yeah, okay, so thank you so much. So I see a question from Eric.
Yeah, Eric Vink, no specific yet here, but I'm really puzzled to see on this slide, the second bullet, dynamically adapting to outgoing traffic for a working group where the SC stands for static context, right?
Yeah.
So don't optimize traffic, maybe say something in the document that says adapt to new traffic flow, right? So for instance, you were using UDP for doing this, and then you do UDP for doing that, right? Don't compress. I mean, I'm very uneasy with this sentence.
Yeah, it's a good observation, and it's very logical. So the way we're trying to, like, we should probably pay attention to this in the wording. The way we're defining this is it's still static because during a certain communication, the like rule 8 should mean exactly rule 8 on the other end. But yeah, over time, so there was rule 9, for example, that didn't exist before, but when rule 9 is used, it's exactly the same in both ends. So I think we should just pay attention to the wording there. Thanks.
Yes, to answer that, the static context, this means that when you do compression or decompression, the context do not evolve. So it's, and then what you do with management is that you add new rules that can be better, so they will be selected. But it means that we still keep, what is good with SCHC is that we stay in the datagram mode. If we lose one packet, we lose one packet. But we don't lose the rest of the sequence because something has evolved and makes things understable. So that's here where we have static. Then we can have a way to add new rules when you learn more about what you are sending.
Quentin. So there is Quentin and then Kirsten.
Yeah, I just wanted to confirm what Laurent just said. Our understanding is that the protocol is static in the sense that it's stateless. There's no running window of packets that is being kept for doing the compression. So we update the rules and it's on the control plane. And this is done infrequently, but when we consider datagrams packets that we compress, all of the rules are in effect static.
Kirsten.
Yeah, Carsten Bormann. Header compression has about a 35-year history in the IETF, I think, around the 1990s, when Jacobson made his header compression scheme available. And the fun part has always been synchronizing the state on the compressing and the decompressing side. So as long as these updates are essentially updates to stable information, which is another word for static. I mean, it may be changing a lot, but it's static in the sense of there is code that maintains the stable information. And as long as that is synchronized with the actual interchange of the packets that uses a particular version or revision of that stable static information, we are fine. Only protocols like ROC, which actually implicitly update the state from packets received, which of course can be very, very efficient. They have a problem if one of those packets gets lost, in particular when the compressor has actually operated on it and the decompressor doesn't get it, so it cannot do the state update that is required. Then you need all these robustness mechanisms that make ROC complicated. But as long as you treat this as state that is actually managed, you only have the concurrency problem left. Only. And if you can explain to me in the bar at some point how you manage that concurrency problem, I will.
Okay, thank you very much. And Mariam, yes, you have something to.
Thank you for your nice presentation. I just, so about the security aspect that you mentioned, that since we are having the encryption and so we have, it is secure, but I think that this is only providing confidentiality, and I was thinking that, is there anything considered for replay protection and for reliability, as it is very important to make sure that the rules are changed on the both ends or not, or it is going to be something as future?
Yeah, for now we're not looking into the details. We're still developing the core function, like core capabilities. But yeah, like depending on the environment, you should use the encryption mediums, that like methods that you have available. And for example, we do recommend on the draft, like we do state that, for example, if using the core conf interface, you use confirmable messages, so that we make sure that they appear there. And so in this case, for example, if a management packet never reaches the destination, well, for example, in this case, the device would never send the rule 9, and rule 8 still exists on the other side. So eventually it's like, yeah.
So we're at the end of the time for a presentation, but I just wanted to come back to Eric's remark, and then a lot of the input that you have. I think it's really crucial that you have the right wording in the draft, yeah. Because it's like really the first time that we're entering in this area, so that it's really perfectly well defined. And I think that you had a lot of very useful input from Karsten, from Laurent, from Quentin, from Miriam. Maybe make it like a separate section, like to say what.
Yeah, I think these last 3 feedbacks converge into this, like having good wording.
Yeah. So that's really important.
Yeah.
And another thing is, so there will be some other presentations. So I probably, maybe I get the feeling that there will be maybe multiple drafts or multiple RFCs treating different aspects of the management. Like maybe it's not going to be like a universal solution, right? It can be different use cases, or I don't know even how to say that, right? So I think that it's the right time for the people of the working group to actually read the draft really carefully, because I think that soon we'll be asking for working group adoption. And when we ask for working group adoption, I think it will be nice that we are able to really scope it well. So, okay, well, this specific RFC or this specific draft is going to be addressing this use case and in this scenario and that, right? And I mean, I'm not sure it's going to be like a universal solution for any kind of management for any use case, right? So please read the document and provide feedback.
Yeah, just provide feedback, and for this, like for now, I think there's already enough content to release the second version, so it should be coming.
Okay, thank you.
Thank you.
And now, Quentin and Marion, I'm not sure who is going to be presenting, and you can turn on your camera as well. So I think you have around 25 minutes, but is it 25? Okay. So I'm going to start a timer, and I'm going to give you the control, so you can change your slides. So
right.
you can,
yes. Yeah. So we'll do both the presentation, but I'll talk and Marion will interrupt. So yeah, just a quick word. This is about a draft that we published during the summer. The name is SCHC Minimal Architecture, and actually it's a work of Marion, Philippe, and myself, Quentin. Next slide. So what we're going to cover, I mean, really the reason for this presentation and is the reason for the draft. The draft has been released during the summer and it provoked mixed feelings and reaction, and we wanted to clarify the objective of the document. We believe that the name that we gave to the drafts might be misleading. And yeah, really the objective of this presentation is to clarify the purpose of the draft, what's inside, what's the kind of contents that you will find within this document. Also walk through the methodology of the document and actually provide some of the outcome of the discussions that are in the draft. Next slide. So why this draft? So basically this follows a call from our chairs to actually review and provide feedback on the architecture document. This also follows the discussions that we had during the last plenary. And really what we wanted to do is to actually read the draft and try and explain every choice, terminology choice, functional choice that is being described in the draft architecture document. So we did it. We read the draft and we tried and explain how things were articulated. And so this was quite difficult. And so at some point we said, okay, let's start with a very, very simple scenario, the one that we all know, the LP1 scenario, 2 devices, 1 IoT device, 1 gateway, and let's start from that and let's build up the requirements. Let's figure out the different kind of entities that we need. Let's discuss terminology, starting with this very simple scenario. And then build up more complex, more realistic scenarios, more in line with what we want to achieve in the SCHC working group, and repeat the process. So really that's what we really wanted to highlight. So the document, I mean, what kind of scenarios are we considering in this document? So as of the current revision, this is the 00 revision, and there's a new one that is coming very shortly. We have considered 6 scenarios. So the first one is the LP1 scenario, a simple case where you have an IoT device and a gateway. And as you can see, we're considering gradually more complex scenarios. So we go from 1 device, 1 gateway to multiple IoT devices and a gateway. And then we add up new scenario constraints, such as having traffic that evolve in time, having multiple instances or strata on endpoints. And then at the very end, the idea is that we are going to converge to a scenario that we'd like and what we envision for SCHC. That is having SCHC able to be used in modern OSs wherever we want in the stack, and compress all of the different kind of headers that we see potential for compression for. So just to illustrate the methodology, this is extracts from the draft. Really, this is just to show how we proceeded. So we started with the very simple case. This is the one that you all know, an IoT device, a gateway, and we considered a very, very simple case where the network stack is implemented as a firmware. Everything is bolted, everything is hard-coded in the stack. SCHC is used to compress IPv6 UDP co-op, and it's part of the network stack. And so we start from here, and we consider the evolution from the LP1 working group to the SCHC working group. And one of the questions that were raised during those sessions was that, okay, in most of the documents, we're referring to devices using IoT device, gateway, and etc. And we found the need for defining the equipment, the network host that is running SCHC. And we felt the need to provide a generic name, and we felt the need that the architecture should refer to those equipments with a generic name. And so in the process, we kind of like try to find the kind of the properties that would define such equipment. So we ruled out hierarchical relationships. We cannot talk about a SCHC core and SCHC device, especially in cases where you have, for example, two routers that are going to compress some kind of traffic. There's no reason for saying one is more important than the other. Obviously, we felt also the need to distinguish the network host that is going to run some kind of SCHC processes from the actual piece of running code that is doing some kind of compression somewhere in the network stack. And well, during this process, then we came back to the draft architecture and we said, okay, the closest definition that we have here is endpoint. So really, the result itself is not very interesting. What's really interesting is how we proceeded, and the goal was really to foolproof all of the definitions that we are using in the working group. And then things started to be more interesting, especially when we were discussing the actual piece of code that is going to be configured to do SCHC something in the network host. And well, to our understanding, this is different from the association of multiple processes that would, for example, establish a session to compress packets. And so, well, this is one of the results, and this actually caused a lot of exchanges on the mailing list. Right now, we don't have a clear definition for this piece of code that is running on a device. And so we came back to the RFCs that are already published, so most notably the 88, 24, 93, 63, and etc. And doing so, we've identified that we use the word instance in those documents for this reason. And so there's been also discussions on the mailing list as to why we should use this one instead of another. But basically, this is the findings, one of the findings that we have done in this document. And so the flip side of this part of the work is that obviously, if we use instance to actually talk about the piece of running code on the network host, so the endpoint, then we actually need to find a new name in the architecture for the session. So that is what we call instance right now in the SCHC architecture document. And so we actually did the work of trying to find out what's the difference between the instance in the sense of the way it's used in the architecture document, and try to propose a new one. And well, the SCHC instance is defined as the session between SCHC endpoints. And so one of the results of our proposal is to actually call it a session. And so this caused a lot of discussions, obviously, and this has impacts on not just the draft, the architecture document, because obviously this would also require, for example, changing some of the terminology that we have on the other RFCs. Anyway, this was for just the naming, so the terminology. We also discussed the actual functional requirements of the architecture. So basically try and find the proper wording for saying what is needed to be in the requirements of the different entities. And one extract of all of the discussions is that in the documents and in many of the documents, we say that for SCHC to be able to work, we need the same set of rules between the different endpoints, so the different instances that are run on the endpoints. And so we actually pushed that concept a bit further, and we said, well, it's not only the rules that needs to be the same, but we think that we have more to that. There's also the need to actually ensure that the field descriptors, so the way the rules are expressed and interpreted in the instances, needs to be specified. And especially there's the field descriptor that needs to be in the same order, because this causes a different way of building the residues, and therefore could cause issues when decompressing. And obviously there's the consideration, is it the implementation? Is it something that needs to be specified? Well, we believe that since we need that to be interoperable between different implementation, then we need to specify it. And if we need to specify it, then it goes to the specification. And there are other topics which we pushed in the appendices, which is about even though we have the same parser, we have issues with the way the data model is built right now. All right. The second use case is actually an extension of the first one. It's actually something that we've also discussed on the mailing list, which is imagine now that we have zillions of devices. And zillions could be, the minimum is 3, 1 gateway, two IoT devices. And really the question that we try and reason about is how do we do the configuration of a fleet of endpoints? So put yourself in the shoes of a gas utility company and you want to deploy gas meters, for example. You have many of them. What happens? And so the use case that we've described is basically this. You have one owner, one tenant for multiple devices. You can expect all of those devices to be very similar, same protocol stack, same header field, similar values. How do we manage the configuration of all those devices? And we believe that saying we need to configure each one independently is something that we should not do. And so if we say so, and if we agree on that, then it means that we have a need in the architecture document for defining a set of endpoints where you will push configuration that are the same. And so same process again, what are the requirements in terms of the terminology? What are the requirements in terms of the functional entities that, the functional requirements for the entities? And so we came up with the idea of having an administrative domain. There's no such definition in the architecture document. And so we did kind of like a review of the existing document, the drafts, and etc. And we found a mention of provisioning domains in the 6 law draft. And so we said, okay, if we need this, then we need to add it to the architecture, and we propose domain, basically. And just for completeness, there's also a discussion on the mailing list regarding the choice of the term domain versus area or zone. Okay, now we say we agreed we need a domain. This domain is going to configure multiple endpoints with configuration, and those configuration will be pushed to instances on the devices. How do we do to provision those contexts to the instances? We need something, some elements of the architecture that will be in charge of doing that. So we have a domain. This is the grouping of endpoints where you will be pushing your configuration. And within this domain, you need a manager. And this relates to some of the ideas that are already present in the architecture document, which is the instance manager. And just to align the terminology with what's already proposed, we're proposing the domain manager. So again, this was for the terminology, and then we discussed also the functional requirements. What do we desire in such a use case? Well, we desire having updates of context at the scale of the domain, so basically being able to push a context to all of the endpoints at the same time. And this actually also raised a lot of discussion. Should this kind of domain be just 2 devices? Should a context, so the configuration that we push to an instance, be specialized for each of the devices, or should we have a single context that is exactly the same that is pushed to all of the devices, which means having a single set of rules for all of the devices? And obviously, the best would be to have kind of like a part of the context that is the same for all of the devices. This relates to the idea of having kind of like template rules or base rules that is shared by all of the endpoints. And obviously, as Anna mentioned in some of the exchanges we had on the mailing list, this would make bad compression rules, because we would have to remove the compression of source addresses, source ports, and etc. And so what we are describing, the scenario we're describing, is that we should have a context where we can push common rules for all of the devices. This could include the management rules that we've discussed in the previous presentation, but also we should be able to allocate special rules, so rules that are customized for specific endpoints to improve the compression rates. And in this case, we also discussed the relation between the context and the set of rules. Currently, the definition of context is a set of rules. And we believe that we had more to that, because, for example, we need to define the direction indication to the set of rules so that it works in the case where the association or the direction is not clear in the architecture. But there's more detail in the appendices, the DNE. Okay, so this is, I mean, we've just had a discussion about that with Eric, the question of now that we are considering cases where we are addressing not only IoT devices, but like more general purpose equipment, then comes the question of having dynamic traffic. And actually, we actually found a use case where it's also applicable to the IoT use cases. The scenario that we explain is that of a smart building use case where you can push different configurations on the sensors, on the set points for different periods of the year. So, for example, say that you set up the temperature of the room to 21 degrees during winter, and when you get to spring, then you want to push 26 for not the heating, but for the AC of the building. And that means that obviously the packets will change, and this needs mechanisms to be able to deploy new contexts. And so if the group agrees that we need to be able to change or to add new rules to the set of rules of the instances in a domain, then we need some kind of entity, again, which in this case is in charge of storing the context within the domain. And we need a name for it. Well, we discussed this at length in the draft, but basically we think that we need to store the context, but we also need to keep versioning for the context. I mean, we haven't discussed yet the question of how do we ensure the synchronicity of the context in the different endpoints, but this will come at some point, I'm pretty sure, and we'll need that kind of property in the architecture. We need to take care of that. So this was again terminology and then functional consideration, etc. And we pushed quite far in the different scenarios, and one of them, one that was actually quite tricky and raised a lot of questions on our side, is the question of having multiple instances coexisting within an endpoint. So this kind of like relates to the idea of stratum and etc., but it actually is quite a difficult challenge. So we identify two main challenges. One is what we call the datagram dispatch. So the question is, how do we dispatch packets or dispatch datagrams, compressed datagrams to the different SCHC instances, and how do we intercept packets from the application, from the above layers, and route them to the proper instance such that the SCHC compression can occur. And obviously, again, this is an architecture document, so every time there is something that needs to be done by some kind of entity, we need to report it. And we believe that we need an entity that does that does the routing, that dispatches the datagram. And we also think that we have a question on a challenge on the instance and context identification, which is actually a two sides problem. One is about the management. How do we address a specific instance and a specific context for updating the configuration. And the other one, which is how do we ensure that when we receive a packet, we're able to actually route it to the correct instance. And some of you are going to say, this is actually covered in the document. Yes, this is section 4, if I remember well. But we believe that there is a missing part in the architecture, which is the dispatcher. Right now, the architecture is kind of like 2 tiers. There's the idea of having a Stratum endpoint and SCHC data endpoints. And the routing is done between the Stratum endpoint to the SCHC routing using this instance ID. However, there is no entity yet that uses the discriminator, and the discriminator is not a functional entity. It's an information, a piece of information that is used by some kind of entity to do the routing. And we believe that this is just something that we need to add in the architecture. Obviously, there's also a discussion on the unique identifiers that we need. Basically, we agree with what's in the architecture document. It's just that we are aligning the names with what's already specified before, and we propose context ID instead of instance ID, but that's not very important. And also, this raises new questions if we consider having endpoints that are registered to multiple domains, because the question of uniqueness of the identifier is a difficult question. Is it unique within the device? Is it unique among the endpoints in the domain? And if an endpoint is registered in multiple domains, then it needs to be unique in multiple domains. Right, we're not going to cover everything because we don't have the time for that, but just to say that all of the scenarios are described in the document, and we would really appreciate if people interested into the architecture would read it, provide feedback, and also contribute if they want to. You will find all of the descriptions that I've just only brushed in this presentation and more. You have the description of the core components, interaction between the different components, etc. And this is material that we hope will be useful for making the architectural document, so the working group document, go forward. So to wrap up, really see it as kind of like a side document, a companion document to the working group architecture. Actually, this is how we see it. Really, this is just a way to list or keep track of all the reasoning that we had when we actually studied, reviewed the architecture document, and the draft is there to record all of that. It's not perfect, so feel free to criticize if you find errors in the documents, something that we've missed, and etc. And yeah, that's basically for wrapping up, because we're getting very close to the deadline. Just a few slides, but we can process that on the mailing list. But this is just to keep track of all of the different topics that the exchange on the mailing list have raised. We have this terminology issue for endpoint instance and session, with all of the RFCs that are stakes, and also the 6 law draft document. There's the question of do we want pairwise or do we want domain-wise configuration of the equipment? There's the question of is a context a SOR or not? And if it's not, then what needs to be in the context? And this should be reflected in the Yang data model. And plenty of others. I'll stop there. So there is time for a few questions. Sorry.
Thank you very much, Quentin. So Karsten is there. I just wanted to interject something. So I really like the way you presented the whole your work, and just my takeaway from this is that we could see it something like a super deep review of the SCHC architecture draft, where you went and really imagined, like there are some easy and natural additions, there are some future looking stuff, and there are some things that move the terminology a little bit around, and this is one so there are three parts, right? And just wanted to see that. So Karsten.
Yeah, Carsten Bowman, what Alex said is this is really amazing work. And keeping your terminology under close watch while you are developing and things become more complicated is really a major objective for work like this. I'm really impressed.
Thank you.
Yes. So thank you, Karsten, for that observation. Yes, and I think that it really merits a much longer discussion. I mean, it's a really very deep and detailed review, like of the SCHC architecture draft, and we should definitely take more time outside of here and during the interims and on the mailing list. But one thing is to really see how things can be merged back in the SCHC architecture draft, right? Because here there are some, and probably we'll be getting also back to the working group, because some things are changing, like the SCHC instance. And thank you, actually, you found out that there are cases in published RFCs that we're using the SCHC instance word, right? So is this a problem? I don't know. I think that's a question for the working group, right? So Laurent, maybe a quick.
Yes, that's a good analysis of what has been published. That is also work in progress, so there is a lot of inconsistency on what has been done. But for me, an architecture is also a bottom-up approach. It means that we have building blocks. From these building blocks, we create other blocks that we put together, and still we can go to to then describe what we want to do. For example, it's point-to-point, it's something with different layer, etc. So we have already some things that have been done. The vocabulary is not very clear right now, but I think it's very important to finish that work very, very quickly, because we see that other groups are using the vocabulary, and I saw Bob this morning talking about Statum and all these things. So we need to fix it quickly, otherwise we are already in a lot of confusion, and if we continue, then we will have more confusion.
Yeah, agree.
Okay, so thank you, Quentin. So we will continue this work on the mailing list, and Karsten and everyone, your review, it's really precious here. And what Laurent said is really important as well, so that we can move on with this. So in some kind of a continuation of the work of Quentin and Marion is really very specific work. Like they did this deep review of the SCHC architecture draft as it is today, and here I'm going to do a very wide, almost researchy presentation. So it's really that there were a couple of questions. Okay, how do we do actually management over point to multipoint and multipoint to multipoint links? And so this is not going to be like a solution, right? This is just putting some considerations for the future solutions that will be made someday, which can be, in 50 years, I don't know, but whenever people deem that it's important, right? So it's really just opening the discussion. I have really not much time compared to what I planned. So basically, two basic scenarios just to fix the ideas, but like there can be many more. So you can imagine like something that here is called primary, but like it's like in a LoRaWAN when you have like a SCHC gateway, and in it multicast, it sends multicast packets to smart meters, for example, over LoRaWAN. So this is one use case. In another use case is, well, if you have SCHC over Ethernet, then you can have like multi-point to multi-point kind of traffic, right? So these things exist, and so we have, of course, like star topology, mass topology, and there is one thing. So we have the Yang data model there that provides a way for the state of for the set of rules to be expressed. Now, the first thing is that like CoreConf, we talk about a lot about CoreConf, and I'll be talking about CoreConf, but CoreConf is not the only way of actually managing these things, right? In DLMS, when they adopted SCHC, well, they defined, actually, they used DLMS to manage the SCHC state, the set of rules, because like it was already there, right? And actually, netconf exists. So if you're running SCHC over routers, then you can use the netconf protocol that's already there, right? And netconf can actually has the notion of transaction, which is per router. You can like enable it, like do a commit, rollback, and all that. And if you have like a mesh kind of topology, well, your SDN controller can actually orchestrate that. So actually, in some way, you can have, with today's tools, you can manage your set of rules, and you can manage your SCHC context in very complex topologies. So that was just like a high-level 10,000 feet view of the problem. But then when you look a little bit more in detail, of course, CoreConf can be super useful for constrained networks, constrained devices, or if you want to have like a, how was it, like a zillion devices, right? Probably you would not want to do that with netconf, probably. So here it's just like some ideas that, hey, well, of course, the goal today is to define how this management is done over point-to-point links. But actually, we can leverage that and to do management in more complex situations. And there are a couple of terminologies that are just thrown out there. They don't have to remain like this. And it's just things that I think were mentioned even in the draft of CoreConf management. Like it's your set of rules when your device boots up for the first time, it's configured with something, right? And we can call that like the factory defaults set of rules. Then, that becomes the configured set of rules. It's like on a router, on a netconf router, they have like the running configuration and the safe, what was the configuration? Anyway, and so upon starting a communication, then you can have like a session, like a PPP, or like you have this notion of something gets established. Well, then you have this configuration that can be downloaded, and then that becomes your runtime set of rules. That runtime set of rules can be modified through some protocol, and then that can be stored on your device, which becomes then the configured set of rules. So we have these two terminologies to keep in mind, and I'm going to give a very specific example. So we're talking about SCHC, but we're using only for compression, so it's stateless. SCHC doesn't provide any message delivery guarantees. So in case your multicast message gets lost, well, I mean, it's not SCHC's responsibility to add reliability to that. And here we have like 3 rules that are like the factory default set of rules. The first one is 1/8 bits no compress. Then we have 2 rules for management. One is for unicast management. The other one is for multicast management. And here, I hope someday to see co-op group communications over this, to be able to do the whole thing. So, but that's probably like a little bit further down the road. Anyway, so I think I clicked. Yeah. So there are 2 examples. So these are the 2 examples of the management rules. So I'm going to be super brief. Like basically, all the things that could change are sent. So some of the things are computed, not sent, but basically we're sending a lot of things. So here I'm just giving an example for the IP and the UDP part. Of course, we can go to the co-op part if you want. So this is for unicast management rule over point-to-multipoint links. And we can have also multicast, where basically where we're saying, well, we can compress the prefix of the multicast destination. So these are things that are configured, and now this is an algorithm that takes a point-to-point management protocol and applies that to a point-to-multipoint settings. And here there are actually 2 things, and this is Quentin's presentation that made me think about it. Is when we talk about these point-to-multipoint things, well, we can think about it, the traffic, the data that's going, for example, firmware update over the air. This is where multicast traffic can be very useful. But we can also think about it for the management part, where you want to maybe configure multiple contexts in the same time. So here, this is basically using unicast messages to configure one by one all the devices in the network, and then to enable them to start operating. So using the multicast for the data part, right? I'm not sure if that was clear enough. So there are two things here. The first thing is, what I'm talking about, yes. So establish some good principles about like like rule of thumb, so that we can actually build a robust management system, right? The first thing is that rule ID or rule ownership must be clearly defined. So if you have a network where there are devices out there and anyone can create rules and delete rules, it can become messy pretty quickly, right? So if you say, well, there's this one central node and it is the only node that can actually create rules, it's super simple. Like it's this. Then maybe if it's very dynamic, you need to vote who is that node and so forth, but that's another point, right? So you need to define the ownership. And then the consistency of the whole rule ID space in the whole network is managed by this node. And then probably it would be a good idea to have something like a restfulness, where basically you can only create or delete rules, but not modify them. And then stuff like, well, if you send 50 times create a given rule, and if is the same rule, well, it works, it is the same operation. And there is one thing that I think it's super interesting about SCHC, and very particular, and I think that here we can have a very specific solution to our working group and to our technology, is that we can have a transient state in which some of the nodes are configured in some way and some are, like there can be a slight difference in the configuration, but the network works well. So it's not as in database where you need to make sure that everything is the same and then commit, and if something happens then it is broken. No, it's like a transient state. So let me just be a little bit more specific about that. So a transient state is a state in which any SCHC datagram which is received can be processed correctly. So that means we can imagine that some of the rules are actually disabled for compression. They exist for decompression. So if you receive a rule with rule ID 5, the rule is there, well, you'll decompress it, but you will not use it for compression. And this can be used to actually manage the network. Well, you can create many rules, they're all disabled for compression. And then when you ensure that all the rules have been created, you start enabling the compression, right? And the whole thing will work, right? So this is where we can say, well, we have the transient state and the consistent state. In the consistent state, like all the state of rules, all the set of rules are the same, right? So here in the presentation, there is actually a description of how that works. Like for each node, blah, blah. I tried to add some animations, so please excuse me if it's not formally well described enough. So here we have this primary controller that is going to be configuring over a point. So it can have like a bidirectional link to each of the nodes. So think of these like smart meters, and this one is going to connect one by one and is going to update. And these are the set of rules on all of them. So first, it stands, okay, well, I'm creating a rule on the first node, on the first meter. The rule is created, but it's disabled for compression. And it can actually verify that, okay, that actually works. Yeah, okay. Then is the second one. Oh, it's really validated. The next one, it's validated. And the final one. Now, all of them, so this is a stable state. They have the same, is consistent state. They have the exact same set of rules. And then one by one, it starts enabling them for compression. And so at that state, there can be packets in the network that are compressed with rule number 4, but each of the nodes will be able to decompress them. And so we end up we end up in a state in which all of the state of rules are synchronized. Laurent?
We have finished or?
No, I have a. So the same algorithm exists for deleting rules, where you can go and delete one by one all the rules, and first you go and disable the rules one by one from all the nodes. Then you wait for some time to make sure that there are no packets in the network that are using this rule, and then you can go delete them one by one, right? And this is like a baseline thing. We can imagine things that use actually the real multicast, where you can send a multicast several times, you send the create, and so forth. So anyway, I really need to accelerate here, but there are a lot of questions, and I gave examples here. Oh, that was my backup slide. So a lot of terminology, but I think so this shows that it's feasible, right? And there are things to be discussed. Laurent?
Yes, I'm not so optimistic regarding what you say about multipoint and point-to-multipoint. So there is, for me, four different things that make this not very usable. First, if you look at the charter of the working group, there is nothing mentioning this. The only thing we have in the charter is a pair of nodes. So pair of nodes is not really multipoint. So if we want to go into this, we need a very strong discussion for rechartering. So to see how we do that. I'm not a legalist, but the other thing is that there is a confusion between the protocol that can be multicast and the compression, which is not a protocol. It's just a way to transform a format to another one. And you can have, if you are sending point-to-point things and you don't put the address in the rule, then you can have the same rule everywhere. If you are doing multicast, maybe you have the source address that differ and you have a different rule for each multicast flow. So SCHC by itself is totally decorrelated from what you are doing at the protocol level. So that's something that we have to take into account. So for me, saying multipoint is not prime of SCHC. And the other thing is that we have the historical things about SCHC that has been done in point-to-point. So we have a lot of things that are related to that. We have fragmentation that is only point-to-point. We have the direction that makes it point-to-point. We have the management also that makes that right now we know maybe, I'm not sure, but we hope so, to do management in point-to-point with acknowledgement. If we are sending it on a lot of nodes, how we can guarantee all these things? So for me, it's something that we need to take into account in the future, as you say. But first, let's make something that works in point-to-point, having in mind that it can be in the future multipoint, but let's stay on something we can handle and standardize quickly.
Kirsten?
Yeah, those rules about when do you make state and when do you break state, that is, of course, exactly what we defined for 6.2.8.2 for the 6LoWPAN header compression, where the context is the word we use for the state that governs compression and decompression. The context actually needs to be established before you can use it, which is kind of trivial, but that also means that before you actually can change context state, I mean, you can always add state, but if you want to change existing state, you have to make sure that everybody stops sending packets. So the context in 6LoWPAN is in the area. We have area context. So this is very much multipoint, a multipoint situation. And we have to make sure that this is properly managed. So we never made a lot of details about that. But I think the rules are pretty obvious and they are already written up in 62.82. And now the only, we can reduce all of our problems on a previously unsolved problem, which is reliable multicast. And we know that we don't know how to do this, but that is only true if we have completely idealistic ideas of what a reliable multicast must be. And if we scale this back to what actually makes sense, you can very well have very good reliable multicast mechanisms.
Thank you, Carsten.
So Eric, as usual in this meeting, individual contributor, no hat. I got two minor problems. One is it's typically used on constraint nodes, and I see new rules, and no garbage collect. So at some point of time we'll be facing it. Maybe it's there. And the other point, pretty much like you, multicast in real life doesn't work like we hope, right? So and you get a step where somehow you are waiting until all the nodes has got the rule 4 being received and acknowledged, like a two-phase commit, by the way, of your database before, right? Before using it, you will never reach this state if you have, like you say, 110K smart meter. Most of you know it, right? But thank you.
Yeah, we have a word for that. So when we worked on early multicast protocols, we always had one member in the group that can be described as the crying baby, the one that doesn't get it. And you have to have an idea how to manage such a situation when you want to do your updates per multicast.
So just on that point is, I think that it really need to. Eric, yes, there is the delete actually, and you can go and delete the rules, and this is how you do modification. By the way, if you want to change a rule, you create a new, and then you delete the old one, right? And but I think it's really important to actually define the use case for which that things work, right? So you can have the crybaby, but you can say, well, I mean, there are solutions to be made, but actually scope it. But then probably a question to Eric, to RID, because we had on the mailing list a call for, at some point that was discussed, and basically the working group, that there was a rough consensus that this is a use case that we want to address, like point to multipoint and multipoint to multipoint. And now there's the question that in the charter, actually, it says that it's a pair of nodes, right? So does the charter forbid us for treating point to multipoint?
I mean, I will need to read the charter to be sure, but if the charter is explicit, is point to point, yes, we may not do this. Now, using some time of the working group to present a non-adopted document, like you did, that's fine. Going further, no way. I'm sorry.
So should we remove that from the architecture?
Or recharter, yeah.
Or
remove it from the architecture then. I mean, it's painful, but break my heart as well. Be sure.
Okay, sure. It's a little bit problematic for me personally because there is an IEC standard that uses that, and there's a DLMS and LoRa Alliance standards. So basically, we cannot cover that with our architecture.
So in this case, and you are the chair as well, right? Consider recharter. We can talk, if the working group allows, right, to recharter, we can do it, and the IETF later. Okay. And it's not complex, right? Many working groups have been rechartered this year.
Okay, thank you.
So, as a chair of the co-working group, of course, one of the main redeeming features of CoAP is that you can do multicast. I mean, we all know, as Eric said, it never works the way that it's told in the textbooks, but you can do useful things with multicast. And given that we have an environment where multicast actually can be very helpful because we have these 10,000 lights that need to be switched on and off at the same time and so on, I think it's a good idea to investigate that. And I didn't find anything in the charter that would be against that, but I think Eric is better in reading charters than I am.
Okay. Yes. So thank you very much. There's some, so the time is up, and I really need to apologize to Rodrigo because Rodrigo actually sent a draft, the presentation update of the. With me.
Quentin, you have a quick remark?
I don't know if it's quick, but just to mention that we are discussing point-to-point in two ways. We refer to point to discuss the question of the data or the traffic scenario, so what we compress. And we also consider point-to-point in terms of management. Right now, we are mixing the two ideas where we say we only consider point-to-point traffic, so not multicast traffic. And by extension, we say that the set of rules is going to be point-to-point. And the management and how we deploy the rules, the context to the devices is going to be point-to-point. I believe that we could do deployments to multiple points of the same context and yet still have point-to-point traffic patterns only. So the idea is that if multiple endpoints have the same kind of traffic, push the same kind of rules to all of the devices. It doesn't mean that we are going to let them use the rules on multicast traffic.
And as just one word, Anna?
Okay, 2 minutes, no more.
We can have a hallway meeting. We all want to hear what you have to say. So we just stay in the room and listen. Okay. Don't compress your stuff down to it's no longer useful.
Okay, no problem. Okay, hello everyone. I'm going to talk about the difference between the version 0 and version 1, the new version of the draft. Then let us recall the problem. Chick works on, well, when Chick worked on links with delay or interruptions, we have three main problems. Well, if there are long delays, then Chick can expire. As a result, Chick sessions ended unexpectedly. Okay, the details you can see in the graph. The second problem is more important because if there are missing tiles, then successive tile retransmission exists, and as a result, increased energy consumptions and transfer delay occur. And the third problem, if there are tiles with error, then inefficient use of transmission time, then as a result, Chick session end unexpectedly. Okay, then we have three problems. I think the last two problems is more important than the first problem. Okay, well, because we have only 2 minutes, this is the detail about the draft. In our design, we have two blocks, or see the two blocks inside the sublayer, the fragmentation sublayer. Encoder and decoder is the first blocks, encoder in the sender and the decoder in receiver, and fragmenter and reassembler in the sender and the receiver. Well, important is the difference between the draft version 0 and the new version 01, because the first draft focused on DTS IoT scenarios, okay? But the new version focus on communication that may or may not experience delay or disruption. Then this draft is more general. The encoding process in the first draft is at the byte level, okay? But in the new version, the encoding process is at the symbol level. This is very important because each profile defines the symbol size based on the error correction code. Then each profile selects each error correction code. And even very important, error correction in the version 1 at the Chick fragment level. This error detection at the Chick fragment level. This is the main difference between 0. Okay, it's very short presentation. Okay, thank you.
Thank you very much. Thank you, Rodrigo. Yes, so Sandra, a micro question or comment.
Thank you. I just wanted to point it out that we got the comments from the group last time that you wanted something more generic, not only DTS, not only satellite, but more delay tolerant, disruption tolerant networks. So that's the idea of this new version. We're not sure if we should publish it with a new name or just a new version because the DTS part is going to go away. So we'll hear from you guys. What do you say?
So, Mark, I think you do you have something to add to this?
Same comment. I didn't look at the file name is just not, what you say is interesting to me, but with that file name, I would never find it. So.
Okay, so we will republish with DTN in
yes,
the name.
okay, yes, I think a new name is
Okay.
to be worked on. Yes.
Yeah.
Yes.
Yes. Okay. Nice.
Tip top.
Okay. So with this, I propose that we end. Thank you very much
No, no
everyone,
problem.
for your understanding.
No, no
Sorry
problem.
and
Thank
thank you
you.
all for staying 10 minutes after the hour. It's, as always, a real pleasure to see you all here and to work on this, and see you in the next interview. Bye. And thanks to the minute takers and the JavaScript.